Hi, in this video we are going to learn how to solve quadratic simultaneous equations. Well, no, there won't be two quadratic equations in this type of simultaneous equations. Only one of them will be quadratic. I don't know if it is any good, but let's see an example. Right, in this one it is quite tempting to equate those expressions because they both are equal to 1. But instead we have to go with rearranging this as y equals 1 minus 2x and then use substitution. So I'll have x squared plus 1 minus 2x squared instead of y equals 1. Right, so x squared plus... Now, it is very important for your calculations to learn how to quickly expand those brackets. It's always the first one squared, so it's 1 squared is 1, and the product of these two, right, 1 times minus 2x minus 2x, but you have to double it, so it's going to be minus 4x, and then you're going to take the second term squared, so minus 2x squared in brackets is plus 4x squared, right? So instead of, writing 1 minus 2x times 1 minus 2x and, doing this and simplifying, you have to go a little bit faster on this. You need to practice this if you need to. Yeah, right. Anyway, let's go on with this calculation. Now I have 4x squared and x squared, so this will make 5x squared minus 4x plus 1 minus 1, which I take to the other side from here, so they cancel each other out. I end up with 5x squared minus 4x, which I can factorize like this. And from here I can say x equals 0, or 5x minus 4 equals 0, which leads me to x equals 4 over 5. Now, this is key to quadratic simultaneous equations. Most of the time, you're going to end up with two values of x or y, right? Whichever you calculate. But just because you have two values of these, now you have to go calculate two y values, right? So you can use this one, but my suggestion is use the original equation, because in case you make a mistake in here, right? I don't know, I always go with the original. So I go like 2 times 0 plus y equals 1. So from here y will be 1. And 2 times 4/5 plus y equals 1, so I end up with 8 over 5 plus y equals 1, where y would be minus 3 over 5. Now, if you leave your answer like this, you're not going to get the accuracy mark. You must make sure that you pair each x and y value. So at the end of it, you should write something like this. X equals 0, y equals 1, because that happens when you substitute x into the equation, and x equals 4 over 5, y equals negative 3 over 5. So you should have the x and y values properly paired, otherwise you will lose the accuracy mark. Another example. Right, in this one we have the product of two unknowns, as you can see here in the second equation. U times v is 6. Now you could go arranging this one like either v equals 6 over u, or you could write u equals 6 over v. But then when you substitute one of these into the first equation, you're going to end up with a fraction at the end of the day. So my suggestion, if possible, is to arrange the first equation. So instead of this, you could go like v equals 7 minus 2u, right? And you can substitute this into the second equation. So you're going to end up with u, right, times 7 minus 2u instead of v equals 6. So initially you might think that, well, where is the quadratic equation? There you go. It is the product here which will give you the quadratic. So it's going to be 7u minus 2u squared, and you take 6 to the other side to make it a proper quadratic equation. And rearranging it with the signs all together, because I have to change the signs now, it's going to be 2u squared minus 7u plus 6 equals 0. Solving the quadratic, you're going to get u equals 2 and u equals 3 over 2, which you have to substitute for v. So I'm going to go like in the second equation is going to be 2 v equals 6, where, well, v would be 3, and if I substitute the second one, it's going to be 3 over 2 v is 6. From here I can say that's going to be 3v equals 12 and v equals 4. Now comes the pairing. For u equals 2, v equals 3, and for u equals 3 over 2, v equals 4, right? So this is how I solve this simultaneous equations. Right, let's look at this one. So here, of course, I'll rearrange this one, right? It's going to be 2y equals 7 minus 2x, or if you'd like, 2x equals 7 minus 2y. Now, I'm going to choose this because I know if I take the square of both sides, I'm going to end up with 4y squared is 7 minus 2x squared, and I have 4y squared here. So what I'm going to do is, without dealing any fractions, because, you know, otherwise I had to go like y equals 7 minus 2, sorry, not y, x over 2, right? Or for this one, x equals 7 minus 2y over 2. Just because I can see this, I can just use this and substitute into the second equation. So it's going to be like x squared minus 7 minus 2x squared, which is 8. Well, this is difference of squares, as you can see. So it's x minus 7 minus 2x in brackets times x plus 7 minus 2x in brackets, which is 8. So if you expand the brackets, that's going to be, let me write underneath and then simplify, x minus 7 plus 2x, that is x plus 7 minus 2x. So I'm going to end up with x plus 2x being 3x minus 7 multiplied by minus x plus 7, which is 8. Well, I cannot figure out anything from here because this is not equal to 0 at the end of the day, so I have to do the expansion anyway, but that's gonna be slightly easier because I use the difference of squares. So I'm going to end up with minus 3x squared plus 21x plus 7x minus 49 minus 8 equals 0. I take it to the other side as well. So that's minus 3x squared plus 28x minus 57 equals 0, which will be 3x squared minus 28x plus 57 equals 0 when I arrange the signs. And from here, so if you solve the equation, you get x equals 3, x equals 19 over 3. For each of them, you have to calculate the y value, and you will find it as, right, y equals 1 over 2, y equals minus 17 over 6, and, well, you have to pair them, needless to say. x equals 3, y equals 1 over 2, x equals 19 over 3, y equals minus 17 over 6. Right, so we have two simultaneous equations here, two sets of simultaneous equations. You are solving these on your books, please, and submit your answers online. Thanks for watching.